Welcome to an updated demonstration video of the latest version of our digit management system. We've upgraded the software to be 64-bit. This was running on Windows 10, and we've used the latest development tools to create this updated version. Now, digits are our data objects. We have many different kinds of digits. One of them is file digits, which we use to mimic regular files. We also have things like tag digits, which are key value stores. We have sets, can mimic folders. We have markers, security, all kinds of different kinds of digits. Now, to show you how we create our file digits, I've got a couple of containers here, container 1 and 2, in which I've imported a bunch of files or created a bunch of test digits. Show you how this is done. We'll come over to our regular Windows File Explorer here and drag and drop a folder, in this case program files, over to our general file migration drop zone, which then finds all the files within there and converts those into digits. So just like that, it created 1234 and attached a bunch of tags. We attach a bunch of file system information as tags onto those digits. But we can also create these test digits. So I come over to my other container here, and I previously populated this thing with 42 million of our digits. And I'll just show you quickly how to create another 100,000 of them here. Select the software, type in 100,000 here, hit create. Takes a couple seconds, and just that fast I've added another 100,000 of our test digits to this container. Now we go over to the query tab and try to find everything. So for example, we want to find our software. We see we have 2,102,000 pieces of software that we've created in this test digits. We're going to find everything. Let's see, this is all our files. There were 22 million of them out of our 42 million were private. We have a public one. Here's for public. There's the other 20 million. So you see, I can very fast. I can sort out all the documents, all the photos, videos. So here's our videos. We had 10 million of them. 10 million and 2. Just sorted those out of the 42 million objects out there. Now let's go to the other container where we converted real files into our digits. So here we just found all the videos. There were 84 of them. Find all the scripts. There's 5,000 of them. Here's the photos. There are 19,000 documents, etc. All these queries take less than a second to find all the different kinds of files and digit types. We can go to our status page, and this will give us a breakdown of all the different digit types that are in that. And within the files, how many of them are audios, how many are pictures, how many are text documents, etc. This will tell you instantly how many different kinds those 268,000 different files are. I mentioned that we automatically attached a set of tags as we converted those files. So we come over to our tags folder here, and see that we attach things like the full path for a file as a tag, its parent directory, each ancestor in its path name, the folder names themselves, and just the file name. If I click on, say, folder name, so we instantly look at that tag and see there were 32,928 different folders in our hierarchy of our tree on our C drive. And of those, 87,304 files had windows, with mixed case actually. There's another one with all uppercase, even more, that had that as a tag. So if I just double click on there, there's the 87,000 different files that had windows. If I just double click and pull up its properties, you'll see, yes, indeed, this has windows attached as a tag. And we can attach hundreds of tags to each individual digit in the system and find things almost instantly based off those tags. One of the other tags we attached automatically is little SHA-1, which tells us about the data. So if we click on that, we'll see there's 141,000 different SHA-1s, which means they have that many unique files. So for example, come click on this 112, you'll see that this AERTS R64.exe file was repeated 112 times. Each one's probably in a different folder in our Windows directory somewhere. some kind of recovery image drivers for on this system. So, but it was duplicated 112 times in our system. This helps us find duplicates of files and things like that. Likewise, we can come, find all the file names. You'll see that the most common file name was this comcontrol 32.dll MUI. There's 888 files somewhere in our hierarchy that have that particular name. And it's just sorted by the reference count. So of our 268,000, there were only 105,000 unique file names in that tree. Now these tags are kind of like a column in a database. They create hundreds of or thousands of these different kinds of tags and attach all kinds of different values. So we wanted to see how this would perform as a regular relational database table. So let me demonstrate this. So let's come over here, and here I've created a little 1 million row 10 column table and created a little query against it. Show you how that's done. Come over here, we've created a set of database files which are just basically CSV files. This one I've got 500,000 rows, 6 columns. So I come and drop it on my little context, my 6 column definition over here, and it'll import those. So just that fast, I created a new table of 500,000 rows, 6 columns with just names and addresses and zip codes or states and phone numbers, email address, things like that. I could come and I could create a view based off that. We'll just call this, people in B cities. So we want to see all the information where the city starts with the letter B. And if I just click on that, of my 500,000 rows, 37,743 of them started with a city that started with the letter B. If I sort on a different column, you'll see we have Baltimore, Bowling Green, etc., etc. Now each of these columns, I can come and just click on it and say, show me all the values. So I get you instant aggregation of, for the name, for example, Neville Clayton was used the most times. There's about a dozen of them here that all were used 6 times in the table somewhere, and a bunch of them that were 5, etc. So we had 404,000 unique names in our table because it's random first name, last name combinations out of our 500,000 rows. Let's go to the other container here where I created about a 10 or so tables, some of them as many as 5 million rows within them. If I just come and click on, do a select all on that, this one has 2 million rows, 10 columns, and here is all the data. I can do, here's a view of people that lived in cities that started with the word new. So if I just double click on that, sure enough, here's Newport News. Sort on a different column, you'll see Newburgh, Newcastle, Newton, etc. Again, 39,000 out of the 2 million rows. I hit that. Here's people with addresses that started with the numbers 3, 4, 5. Click on that. Sure enough, there were 2,183 out of my 2 million that did that. Very fast. Here's a select all on a 250,000. Here's people whose email addresses ended in a .com in our 500,000 row. There they all are, 83,000 of them. So very, very fast. I think we can give all the relational database management systems a real run for their money as far as speed and performance and the ability to create and manipulate data. Let's show you how to create a quick view. Let's say I want to find everybody that lived in the city of Natchez or Clarksville. I can just come click on these 2 views and say create a view based off those. Instantly it'll say, oh, it's going to create me a view called City Natchez where the city equals Natchez. Let's say we want to modify this one a little bit. We want to say everything that starts with the word Clark. So instead of equals Clark, we say starts with Clark. And away we go. So now we've got two new views on this bit. Here's all the Natchez, and here's all the Clarks. So we've got Clarksburg, Clarksville. Looks like that's the only two cities in our table that had that. But again, 455. So it's very quick way to create some views. This one has 50,000 with north addresses in it. So we can just create new views and view our tables very quickly. Thank you very much.